Oh no, you just spilled grease on your brand new white t-shirt. Normally, we'd think to wash it, but water on its own does not clean, wash, or get rid of dirt, grime, oil, and grease. We know that we use soap, but how does soap work? Within a water droplet, there are many different atoms that make up the water. If we look close enough, we'll notice that water is made up of 2 hydrogens and 1 oxygen. The oxygen have electron pairs on it. Those electron pairs are considered the partial negative part of the water molecule. The hydrogen are considered the partial positive. The interactions between different water molecules, the partial positive and partial negative, create a hydrogen bond. The interactions between these water molecules create surface tension. That's why if you pour a glass of water, water will bead and cling to the side of the surface. Fat and oil, on the other hand, is nonpolar, which means it has no interactions. Soap is a substance that falls under the category of detergents. A detergent is a chemical substance used to break up and remove grease and grime. Soap is the type of detergent which is a mixture of synthetic chemicals, enzymes, brighteners, and perfumes that gets rid of the grease and grime. This is an example of a soap chemical structure. Here we notice that the soap is a base. Fat and oil, on the other hand, is made up of triglycerides. Tri, meaning 3, means that there's 3 chains involved of fatty acid molecules attached to 1 molecule of glycerine. This fat or oil is considered an acid. Soap is considered an emulsifier. That means that it is able to mix 2 immiscible substances to get stains and dirt out. An example of an emulsifier is an egg, which mixes oil and water when baking. The process of making soap is called saponification. That is mixing the acid and base and water to get out the grease and grime. Soap also acts as a surfactant. A surfactant stands for a surface active ingredient, which decreases surface tension of the water so it can spread in wet surfaces to be removed. It combines dirt, oil, and bacteria when using the structure of a water molecule, and also provides alkalinity, which is useful in removing acidic soils. The structure of soap is where organic chemistry comes into play. The long carbon chain is considered nonpolar. And then our action side is considered the polar. These soap molecules surround the oil, and the nonpolar side attacks the oil, while the polar sides creates what is called a micelle around the oil. The polar sides then interact with water, which remove and lift up the grease and dirt to be washed away. Next time you get a grease stain on your brand new white t-shirt, you'll know to not use water, but instead use a bar of soap.